Now, what we're going to do is we're going to extend this idea of finding roots to problem number 2, which, as you could see, since it's x to the 4th, this is a quartic. And since it's a quartic, it's going to have 4 roots. So what I'm going to do is, before I begin, I'm going to list, or I'm going to do 4 dashes. And as I find a root, what I'm going to do is I'm just going to place it in one of these little placeholders. These are placeholders. So as soon as I find a root, I'll write it here, and then I find the next root, I write it here, and then by the time I'm finished, I'll have all 4 of my roots written down. Okay? All right, and so these are going to be the directions that we're going to take. You could see them right here. There are going to be four steps. Here they are right here. The first thing that we're going to do, part A, is we're going to list all possible rational roots using the factor theorem and rational root theorem. All right. So what we're going to do is take the factors of my constant, which is 9, and then I'm going to divide those by all the factors of my leading coefficient, which is 4. So what are the factors of 9? 1, 3, and 9. What are the factors of 4? 1, 2, and 4. So now what I'm going to do is I'm going to make a list, and I'm just going to take each of the factors on the top, divide them by each of the factors on the bottom, and stick a plus minus in front of them. And so what do I end up with? I end up with plus or minus 1, plus or minus 3, plus or minus 9. And then now I'm going to do over 2, right? So then we also have plus or minus 1/2, plus or minus 1/4, plus or minus 3/2, plus or minus 3/4, and I'll squeeze in a couple here, plus or minus 9/2, and plus or minus 9/4. So if you count those all up, 2, 4, 6, 8, 10, 12, 14, 16, 18, there are 18 possible rational roots. So our next task is to find 2 of these rational roots that 2 of these in this list of 18 that work. And what do I mean by work? Well, remember, what we're looking for is we're going to take a root and we're going to plug it into P of x, right? So we're going to put one of these possible roots in. And what our goal is, we want the value of that polynomial equal to 0, because that would indicate that that possible root is in fact a real root, an actual root for this. So because these roots are so nutty looking, I have some advice for you, and that is to use your graphing calculator. There's a reason why you paid over $100 for a graphing calculator, and here's a perfect time to use it. So this is what my suggestion would be. Go to your grapher, and in Y1, place your polynomial expression. And then go to your table. The table is listed, is in blue above the graph, so it would actually be second and then graph, and that gives you gets you to your table. Now, some of you may already have your table set up this way, but some of you might have to change the setting on it. If you have to change the setting on your table, what you're going to do is you're going to go to second window, and when you go to second window, it's called table setup. You want to make sure that your independent variable is on ask. And what that does is that allows you to type in whatever values you want for x. So take a moment make sure that your calculator is set up this way. So right here, second window, independent needs to be asked. Dependent should be set on auto. And then type this into your y equals, type the polynomial into your y equals. And then what you're going to do is systematically type in those possible rational roots. Okay, so I have found that 1/2 and -3/2, out of these 18 possible rational roots, these worked. And remember, what worked means is that when you plugged in 1/2 into your function, you got a value of 0. And so that means that these two are the first two roots that we've found. So I'm going to write them down. Technically, I'm halfway done with the problem, right? There's 4 roots. I just found 2 of them. But to find the other 2 roots is going to be a little bit harder. And this is where we're going to use our synthetic division. And we are going to whittle this polynomial, this quartic polynomial. We're going to whittle it down until it's a quadratic. So here we go. Take either of the 2 roots. It doesn't matter what order you do this in. So I'm going to start with my 1/2 here. And I'm going to do synthetic division with 1/2. I already know that 1/2 is a root. So I already know that my remainder is going to be a 0. So I am going to pop that 0 in first. Drop the 4, and now it's just multiply and add. If you notice, I might be doing this a little bit different. A lot of times teachers will divide first by 2. I divide second by 2. So since it was 1/2, I'm going to take each of these values and divide them by 2 now. I do it at the end rather than doing it at the beginning. Okay. And now what I'm going to do is I'm going to use the next root, which is -3/2, and I'm going to do synthetic division again. Once again, I know that this is a root, so I know my remainder is 0. Drop the 2. And then divide again by 2. Now, what do these numbers represent? Those are the coefficients of the quadratic that is left behind. Our quadratic would be x squared plus 3. The other 2 roots are in this quadratic. So the 2 blanks that I have up top, those will be filled in by solving this. This quadratic is holding or contains the other 2 roots. Oops, I actually wrote a plus. That should be a minus. Oh, should be blue. There we go. Okay. So to find those other 2 roots, you can see that's not a hard quadratic to solve. We add the 3, we square root, and we get plus or minus rad 3. And there it is. There are our roots. 1/2, -3/2, rad 3, and negative rad 3. So what have we done so far? We did part A. We wrote down those possible rational roots using the factor theorem and rational root theorem. We found all the roots over the complex numbers. They happen to be all real roots. And write in factored form. Okay, so we haven't done that yet. So let's throw that in here. Writing it in factored form, we just need to take those roots and write them as as factors. So the x squared plus 3 Here it is. Here's the x squared, x squared minus 3. And then the root of 1/2, that's 2x minus 1. And the root of negative 3 over 2 would be 2x plus 3. And so this is our polynomial in factored form. Okay? You can quickly check your answer by multiplying the lead coefficient, the lead term in each binomial. X squared times 2x is 4x squared, which is what we have right up there. And then negative 3 times negative 1 times positive 3 is 9. That's kind of a quick check to make sure that you've written this polynomial correctly. All right, 3 down. Last one, part D, sketch the graph. Label all real x and y intercepts, exact form, and round it to the 100th. All right, so we're going to first place our roots on our on the graph, and so negative 3 over 2 is negative 1.5. That would be there. Negative rad 3. Rad 3 is about 1.7-ish. And so that would be over here. So we would have negative rad 3. We had 3 over 2. And then we have 1/2, positive 1/2. And then we have positive rad 3. And this would be our x-intercepts. Our y-intercept is 9. Well, that would be way up there. But that would be 9. And this is a quartic. So it's going to kind of look like a nice script W. And so do your best. And there you go. Opens up, leading coefficient is positive. And yeah, there you go. There's your graph. All right. Next video we'll be doing number 3 on the next page.